Hi Beacon, it's Mr. O'Sullivan. Today we're going to be looking at lesson 2-9, vertical angles. So our learning target for today is I can apply my knowledge of angles by extending them to vertical angles. So the notice wondering is going to be a do now that we do in class. So just for instance, like what do you notice? What do you wonder? Or what do you notice and wonder? And notice and wonder here. And then there is a group exploration about straight angles that you're going to be doing with your partners, which will help you dive into some cool stuff with vertical angles. I'll actually do image A for this one. That way you can sort of see the relationship as well. So straight angles are extremely important in geometry. When two lines intersect, they form multiple angles. In the diagrams below, lines GM and FH intersect at E. If any of the four angles formed as a given, all other three can be found rather quickly. Fill in the table based on your knowledge of supplementary angles. So, if we look at the first image right here, they're saying the measure of angle GEF is 120 degrees. So I'm going to go to image A and put a 120. Now, if we think about it, we now want to find the measure of angle FEM, which is right here. If you remember from the other day, we know angles on the same line are supplementary and add up to 180 degrees. So if I did 180 minus 120, that would give me 60 degrees. So that means angle FEM would be 60 degrees. Now, we want to find angle MEH. So angle MEH, well, wait a second, how the heck will I find that? Well, if I look here, that is going to be on the same line as the 60-degree angle that we just found. So if we go through the same thought process in this image, or in this part of the problem, we can do 180 minus 60, and that'll give us 120. Wait a second, we already have a 120 in our image. And then we want to find the measure of angle HEG. So if I go through the same thought process of the supplementary angles, I'm going to use the color yellow this time. We know angles on the same line add up to 180 degrees. So if I just do 180 minus 120, I still get a 60 degrees. So I'm just going to get 60 degrees right there. So if I look at this image, this is what vertical angles are. Like angle HEG and angle FEM are vertical, and then angle GEF and angle HEM are vertical. So when we have angles that are directly across from each other because of two intersecting lines, it will form vertical angles. And vertical angles are always, always, always going to be congruent to each other. So the fact about vertical angles is they will always be congruent to each other. So if I look at this image right here, this angle right here is vertical with this angle, and this angle right here is vertical to this angle. So those angles are congruent. Now, let's look on our next page where we're going to do some partner work. If we look here, it says, find the measure of the angled angles. Provide a reason for your solution. When providing a reason, use some of the terminology we have learned so far. So if I want to find the value of angle 1, I can sort of use a strategy that I was going over a lot in the previous example, and that's about angles on the same line adding up to 180 degrees. So if I do this problem, I can do 180 minus 145, and let's see what that is, because I'm not in the mood to do some mental math. So if I do 180 minus 145 and hit enter, I get 35 degrees. So I know angle 1 is going to be 35 degrees. And my reasoning or my justification could be angles on the same line add up to 180 degrees. Or I can be smarter and more mathy and say supplementary. Okay, now when I look at the measure of angle 2, that's going to have us use our vertical angle stuff that we did in the previous exercise. So if I look here, angle 2 is vertical angles with my 40-degree angle. So angle 2 is 40 degrees, and my reasoning could be vertical angles. Now, when I want to find angle 3, I can use my 180. So if I So angle 3 will be 140 degrees. And my reasoning could be the exact same as my first box, where angles on the same line are supplementary to each other, which will cause them to add up to 180 degrees. Now, angle 4, now that we know angle 3 is 140 degrees, we know angle 4 is also 140 degrees because of the vertical angle package. So we know angle 3 and angle 4 are vertical angles. And we learned on the previous page that vertical angles are equal to each other. Okay, now let's look at some of this partner practice. If we look at this partner practice, question 1 says determine the value of angle 1. So the first thing I see is my crisscross applesauce. I see vertical angles right here. I'm going to mark them, and I'm going to set them equal to each other. So I'm going to do 6x minus 19 equals 3x plus 32. I'm going to draw a line down that equal sign, and I'm going to get all my x's on one side and numbers on the other. So I'm going to subtract 3x, and then I get 3x minus 19 equals 32. Now I'm going to get rid of my minus 19 by adding 19. And when I do 32 plus 19, that's going to give me a 51. Now we divide both sides by 3, both sides by 3, and I get x is equal to 17. Now the one thing you guys are forgetting to do is reading the question. You guys know how to solve for x. The question isn't asking us to solve for s. It's asking us to find the value of angle 1. So if I want to find the value of angle 1, I have to plug back in. So let's plug back in. So if I plug into my 6x minus 19, I do 6 times 17 minus 19. Ooh, have no idea why that erased. So let's type that into our calculator and see what we get. And I get 83 degrees. So this angle right here is going to be 83 degrees, and this angle right here is going to be 83 degrees. So if we do our supplementary rule that we've been talking so much about, we know that angle 1 is going to be 180 minus 83 degrees. So if I do 180 minus 83, I get 97 degrees. So angle 1 is 97 degrees. Now, let's look at question number 2. In question number 2, I still have my vertical angles. It says to solve for x and y. So if I look right here, these two angles are vertical with each other. So I'm going to set those equal to each other. So I'm going to do y plus 23 equals 63. And it becomes a one-stepper. Holy moly, it's an easy equation. I just subtract 23 from both sides. And I get y is equal to 40. Now, in the other example, I need to solve for x, or in the other part, I want to solve for x. So what I'm going to do, like what stands out to me is this one equal. So I can basically say that these two angles right here add up to 100 degrees. So I would do 2x minus 7 plus 63 to 180. I then combine my like terms, so I do negative 17 plus 63, and I get 46. And now I subtract 46 from both sides. And now I divide by 2. So when I divide by 2, I get, I believe, 67. Perfect, 67. get some comments. Alrighty. Now for number 3, we're just going to be solving for x. Don't be thrown off by all those lines. We're just trying to mess you up. But if you look right here and I take out a highlighter, you're going to see an image that we've been seeing in the other examples. Vertical angles. We're just setting that 3x plus 2 equal to 47. So we're we are going to do one of the challenge questions. That way you can sort of see like a more intense one. I'm going to choose question number 1. In question number 1, this is actually going to require us to use some knowledge of factoring, potentially. So, if I look these remember, whenever you have an x squared, you want to get everything on that side. So I'm going to subtract 60 from both sides of my equation. And now I have x squared minus 11x minus 60 equal to 0. And I want to add up to negative 11 and multiply to negative 60. So I draw my diamond, and I think of the numbers that multiply to 60, which are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and I believe that's it. So if I look at my combinations, the only ones that are standing out to me to make an 11 are 4 and 15. Here's the issue though, 4 times 15 is positive 60. I want a negative 60. So if I make my 15 negative, I will get that negative 11. So 4 times negative 15 is negative 60, and then 4 minus 15 is negative 11. So now I have my factor, so I have x plus 4 times x minus 15 is equal to 0. And now we t-time, so we set our factor is equal to 0. So I'm going to do x plus 4 equal to 0, and then x minus 15 equal to 0. When I solve the equation on the left, I subtract 4, and I get x equals negative 4. And then on the right-hand side, I add 15, and I get x is equal to 15. Now, in the first part, we have to figure out if we're going to reject an answer. So if I go to my x squared minus 11x and plug in, say, negative 4, let's see if that gives us a positive angle. Let's see if it gives us that positive 60. So I'm going to type it into my calculator, do negative 4 squared minus 11 times negative 4. Boom, I get 60. So I'm going to keep that negative 4. I'm going to box it. It is correct. Now I'm going to type in 15. So I'm going to do 15 squared minus 11 times 15. And if we look, we are going to keep both of those answers. So x equals negative 4 and x equals 15 are the correct answers for this problem. Okay, so try to see how you do with the other challenge problems. Have a great day, Beacon.